This video is going to give you some important information about the t-distribution. The t-distribution is a continuous probability distribution that's very similar to the standard normal distribution, but it's shorter in the middle and it has fatter tails. Note in the picture down below, the t-distribution is in red, so you see the peak is still at 0, but it's not quite as high as the standard normal distribution, which is in black. The tails of the t-distribution are a little bit higher than the tails of the standard normal distribution. Values of the t-distribution are denoted by t with an n-1 down in the subscript. The n-1 stands for the degrees of freedom. The degrees of freedom is basically a measure of how much information you have about a sample, and it's dependent upon your sample size. Here's a comparison between the standard normal and the t-distributions. Both distributions are symmetric and unimodal, and both distributions have statistics that are interpreted as being the number of standard deviations that an observation is from the mean. On the other hand, the t-distribution has an extra parameter for the degrees of freedom that the standard normal distribution doesn't have, and as a result, the t-distribution changes shape based on the degrees of freedom. Here's a visual representation of what the t-distribution looks like. The red curve is a t-distribution with 1 degree of freedom. It's the shortest in the middle, and it has the fattest tails. This is the t-distribution that gives you the least amount of information that you can possibly have. You can't have a t-distribution with less than 1 degree of freedom. The blue curve is a t-distribution with 2 degrees of freedom. You have more information, so the t-distribution is taller in the center, and the tails are a little bit narrower. We then get to a t-distribution with 5 degrees of freedom, which is the yellow curve, 20 degrees of freedom, which is the tan curve, and it continues to get higher and higher in the middle, with narrower and narrower tails. This continues for as long as you continue to increase the degrees of freedom. Technically, we can have a t-distribution with an infinite number of degrees of freedom. It turns out that a t-distribution with an infinite number of degrees of freedom is the standard normal distribution. So what this tells you is that the t-distribution looks closer and closer to the standard normal distribution as the number of degrees of freedom gets large. It continues to increase in height in the center, and the tails continue to get narrower and narrower as you get more degrees of freedom. Let's take a look at the t-table. The first thing you should notice is that it looks a little bit different than the standard normal table. The values that are embedded inside the table actually correspond to t-statistics. With the standard normal table, we had the z-scores along the rows and along the columns, and we used those z-scores to calculate probabilities that were inside the table. The t-distribution is the opposite. Inside the table are actual t-statistics. The values along the first column give you the degrees of freedom, and the numbers in the top row give the area in the upper tail of the distribution. Notice that this is different from the standard normal distribution. The standard normal distribution table gave you the area to the left of the desired z-score. In the t-table, we have the areas to the right in the upper tail. For example, if you wanted the 80th percentile, you would find the column marked 0.2, because the 80th percentile has 20% of the area above it. Notice also that we don't need probabilities for the lower tail. This is because the t-distribution is symmetric. If we wanted the 20th percentile, we'd look at the column for 0.2, grab the t-statistic from the table, and negate that value. Now suppose we wanted to find the 90th percentile of a t-distribution with 12 degrees of freedom. What we would do to accomplish this is find the row with 12 degrees of freedom, find the column with 10% of the area in the upper tail, and intersect that row with that column. Here's the row with 12 degrees of freedom, and here's the column with 10% of the area in the upper tail. They intersect at 1.356. So what this tells us is that the 90th percentile of a t-distribution with 12 degrees of freedom is 1.356. And just to reiterate the fact that the t-distribution is symmetric, this also tells us that the 10th percentile of a t-distribution with 12 degrees of freedom is negative 1.356.